Assalamualaikum everyone, this is Janatu Sakriya Khondokar and I'm gonna give a presentation on the topic Enhancement of Question Answering System Accuracy via Transfer, Learning and BAR. And before starting, let's get into the topic what this presentation is all about. So as we can see that this paper proposes a framework called BAT-KBQA, which uses transfer learning and BERT to improve the accuracy of Chinese knowledge-based question answering. The paper evaluates the framework on a large-scale Chinese knowledge base and shows that it outperforms several baselines and achieves state-of-the-art results. So we have divided this presentation in three different parts. First one is summary, second part is limitations, and the last part is synthesis. So in the summary part, firstly we are going to talk about the hypothesis of this project. So yeah, as we can see that the paper proposes this framework. The paper also introduces some novel techniques such as using character segmentation and self-attention for named entity recognition and using predicate features for entity disambiguation and predicate mapping. The paper evaluates the framework on a large-scale Chinese knowledge base and shows that it outperforms several baselines and achieves state-of-the-art results. This paper aims to address some of the challenges and limitations of existing methods for Chinese knowledge-based question answering, such as the complexity and ambiguity of Chinese entity linking, the lack of association between entities and predicates, and the difficulty of generalizing to different domains and knowledge bases. And then we are going to talk about the contribution part, where firstly it proposes a transfer learning approach and then it designs a BERT CNN model for entity disambiguation that incorporates the predicate features of the candidate entities, and also it develops a BERT softmax model for predicate matching that also uses the predicate features of the answer entities, and lastly it conducts extensive experiments on a large scale Chinese knowledge base and demonstrates the effectiveness and superiority of the proposed framework over several baselines and existing methods. Then we can focus on the methodology part, where the paper adopts a data-driven and deep learning-based approach to build the BAT-KBQA framework. It uses a pre-trained BERT model as the backbone of the framework and fine-tunes it on different subtasks of Chinese knowledge-based question answering. It also uses a BIL-STM-CRF model with a self-attention mechanism for named entity recognition, a CNN model for entity disambiguation, and a softmax layer for predicate matching. It combines the source of entities and predicates to select the final answer from the knowledge base. And in the conclusion part, the paper concludes that the proposed framework can effectively improve the accuracy of Chinese knowledge-based question answering by using transfer learning and BERT. It also suggests some future directions for future research which can be very helpful in the future. And then let's focus on the second part, which is limitations. There are three limitations that we found on the paper. First limitation is it relies on a large amount of annotated data for fine-tuning and the BERT model, which may not be available for some domains or knowledge bases. In the second limitations, we can see that it does not consider the semantic similarity or diversity of the candidate entities and predicates. And in the third limitation, we can see that it does not handle some challenging scenarios such as questions with multiple entities, predicates or answers, or questions that require reasoning or intervene. And in the last part, synthesis, we can see that this paper presents a novel and effective framework for Chinese knowledge-based question answering, which can be very useful for various applications such as intelligent assistance, information retrieval, and knowledge discovery. This paper also provides some insights and techniques for enhancing the performance of natural language understanding and accessing, such as using transfer learning, BERT, and the predicate features. And also, this paper opens up some new possibilities and challenges for future research, such as extending the framework to other languages and domains and incorporating more knowledge, sources, and reasoning capabilities. The system may fill up the gap in the technical research of the tutor selection service system in future work. If different subtasks can be trained in combination or more knowledge graph representation learning methods can be introduced to obtain richer features. And that's all from me. Thank you, everyone.